welcome to Code, and today we'll be looking at another cup of code, but we want to discuss 5 critical Java object-oriented programming principles, and let's get right into it. So what we want to start with is Java and object orientation. So what is object orientation? So object-oriented programming is a programming style that uses objects that contain data, methods to perform procedures or run processes on the data. So also going further, object-oriented programming is a methodology to design a program using objects. And object-oriented programming in Java follows the dry as well as solid principles, giving it more clear structure, easier to maintain, debug, and modify. So dry is don't repeat yourself, which means you code once and reuse everywhere. So that's the method that is very efficient in Java, and that's what one of the capabilities of Java. And the solid principles, we'll be going deeper into this in a separate video, but this is an abbreviation for the single responsibility, open close principle, list of substitution, interface segregation, as well as dependency inversion. So these will be diving deep into them, see how you can also get these into code and see them in action, so that also when you see it in enterprise applications, you're not shocked as what is going on here. You can just easily spot which principles have been implemented, and also how you can enhance your code for high performance and high scalability, as well as easier maintenance, debugging, and updating code going forward. So in a nutshell, that's what object-oriented programming is, and the use of objects is essentially very key because it informs us what the state of the objects are, and the behavior of those objects by defining those in our Java class, essentially. So in the discussion below, we'll be looking into a Java class, inheritance, abstraction, encapsulation, and polymorphisms, which are the very key monomers of object-oriented programming, and how we can use this in our daily code to improve our, or to help write clean code, essentially. So let's go further into discussion and see what we have. So classes, what is a class? A class is a group of variables, methods to form a template or a blueprint of an object. So a class is a blueprint, or it is a template of an object. And an object is a real-world entity like a car, a dog, a house. So those are real-world entities, and an object is a representation of that particular entity. So it has a state, which is the data, and it has behavior, which are the methods that we define within that object. So a class is also a collection of objects. So these objects come in as variables to make a logical entity. So with a class, we create a logical entity, which is a template of a real-world entity or an object, a real-world object, a real-world entity. So in this type of setting, we mentioned a car, a dog, a house. We can also mention something like a banking system. So our entity can be at the end user or the client, and they have methods to withdraw, deposit, check balance, and all of those. So the real world entity is not just these, but it also needs to be defined in the user experience as to what entity are we dealing with at which point. So that is what a class is, and that's what the goal of having a class essentially is to manage the state and the behavior of our logical entity and to interact with the entire system to deliver a particular or to run a particular process for our software. Going further is inheritance. So this is very, very important because what inheritance is a class that inherits all properties and behavior, variables and methods of another class. So which means a class can be a subunit of a logical of another logical entity or of another class. So it is helpful in cases of code reusability where we want to pass in the properties of one class into another class. Um, and also, it's very key in abstraction as well as method overriding. And we will see these as we go further and further down, and you will see these in action. So, a class that inherits another class's properties or features is called a subclass or a child class, and the class that is inherited is called a superclass or a parent class. So if I have a class that inherits another class, then that class will be called a child or a subclass, and the class that I am inheriting from would be a superclass or a parent class. And in this case, we see this in, let's take the example of a dog. So we would say a superclass would be animal. So animal is a class, and we would list the basics of animals, and we would say, oh, let's say domestic animals. Domestic animals, which animals can be domesticated. So we would list the properties of domesticated animals: not harmful, this, that, this, that, this, that, and those would be the properties of a domestic animal. Or if you want to go further, you can say a cat is a domestic animal, a dog is a domestic animal. And let's say, because this is not normal, I'm just going to use it as an example. A tiger, you wouldn't want to domesticate that because the dangers of that animal, it's too aggressive, and you wouldn't want to list that as domestic animals. So because of that factor, that distinction, that it means it cannot inherit the properties of a domestic animal class. It will have to have its own definition, and to, let's say, maybe if you have a superclass or a class of wild animals, you can then list it, or have a tiger inherit the properties of a wild animal because you cannot domesticate it based on the properties that you've defined for the domestic animals and for the wild animals. And that criteria will let you know which animal falls onto which category, and that makes the distinction of inheritance. And because um, these child classes have inherited from the super or parent classes, they're able to use those properties and behaviors of those animals that they inherited from. So that's what inheritance is in a nutshell, as we're trying to simplify this as much as possible so that when we get into the coding part, you get to see this as clear as day. So that's what it is. Let's go to the next one. So abstraction is the next one, as we discussed it previously. So what is abstraction? It is a mechanism of hiding the internal workings of an object. So at this level, we only want to expose the necessary functionality. The primary goal with abstraction is data hiding. So we don't want to give you the details of what is happening here. We just want you to know that, do you want the dog to bark? Just call the method of dog bark, and it does that. As to how or where the voice comes from or how that happened, it doesn't matter. In the same way with a car, what you know in a car, you just hit the accelerator, the car speeds up. As to what happens when you hit the accelerator, what calls what, or which machine starts or does whatever mechanism behind the scenes. We don't care. We just hit the accelerator, the car starts moving, and it becomes quicker and quicker and quicker. That's just what we do in abstraction. So we abstract the inner workings of that functionality. We just give you the functionality and that's it. So you don't have to worry about the nitty-gritties of that. So an abstract class is a class containing one or more abstract methods. It is declared with the keyword abstract. So an abstract class can have one abstract class in it and all the one abstract method in it. Sorry. So an abstract class can have one abstract method, and all the other methods can be concrete. That's fine. And it can also have more abstract methods and also have concrete methods. So that's the definition. Can have one or more abstract methods, and it needs to be defined with the keyword abstract. So an abstract method is a method with a definition without implementation. So the method is there, but it doesn't have any logic defined or implemented or code implemented in it. It's just a definition and it's sitting there. So the reason for that, an abstract method is useful in cases of different implementations, because in the case of an animal, a dog and a cat, they don't bark, but they surely do something. A dog barks, but a cat doesn't. So in this way, if you have in domestic animals, if you have a method of saying scream, something like that, or make noise, yeah, something like that. So if your abstract method is make noise, the moment you call make noise for a dog, it will bark. For a cat, it will do whatever cats do. Don't know what it is, but that's that. Yeah. So in such a case, these are all animals, but they don't make noise the same way. Essentially, that's what it is, and that's what abstraction is in its inner workings. We just want to have the flexibility of different implementations, even though we still have the same method or definition of the method within our class over there. So let's go further, and we'll deal with encapsulation. So what is encapsulation? So in this case, we want to bundle or bind or wrap our data and the methods in a class or a single unit to protect it from external interferences. So we don't want anybody messing up with our data. We just want to protect it and make sure that no one can just get in and do whatever they want on the data or the state of our objects or our class. So the method ensures that data is kept in a capsule type of a container. So the class is sort of a capsule type of a container, which means everything within the capsule itself is protected and can only be modified through the methods inside that are defined within the class or the container or the scope itself. So there is no added scope there because we have inheritance. So you can inherit a class, and because the class, a child class inherits from its parent, you are able to modify the parent state from the child at the child level, and that's what the power of inheritance also gives us right there. But because we have what we call access modifiers, those access modifiers are the only means for us to modify the data within that capsule or within that class. So we can only access the data through access modifiers, which we call getters and setters. So we can set the data for a car. We can set, let's say we want to set the color attribute of the car. We can set the car to red, set the car to green, set the car to yellow. And the only way to change the color of that car is if you call set color, which is a setter for the color on that particular car, and the color will change. And when you get the color of the car after that, the color would be the color that you've passed in on the access modifier. And that's what we want. We don't want someone getting in and go directly to our fields and mess up with the data, yet we don't know what happened um, on at that level of our object. So encapsulation protects us from messing with the data willy-nilly. We essentially need to use the right channels to get to the data and access it the right way. And then we know that whoever is accessing the data is at this level is authentic, and it should be fine to go through. And that's what we want for our code to look like. So going further, we have polymorphism, which is the last and final one. As this will be a quick one, so we just want to deal with that and get it out of the way. So polymorphism, what is polymorphism? The ability to perform a single action or task in many different ways. So you can perform the same task, but if you use different ways or different forms, that is what we consider as polymorphism. We can achieve this by defining a single interface and have multiple implementations. So you know that an interface doesn't have any implementation. It just defines sort of like abstract class. It sort of defines, it gives the definition of what the objects require to do, but the implementation itself will sit within the concrete class or the object itself to say, this is a dog, this is what it needs to do. It needs to bark when it's supposed to make noise, and this is a cat, this is what it's supposed to do when it makes noise. And essentially that's what we want. So polymorphism allows us to have an interface for our domestic animals, and when we call the interface and say we want to make noise for a dog, then we need to implement how a dog makes noise. And for a cat, we want to implement how a cat makes noise. That's what we want over there. And then polymorphism in Java is separated into two types, one being the compile time polymorphism, which is static, and runtime polymorphism, which is dynamic. And compile time polymorphism is achieved through method overloading. And method overloading is essentially we have multiple methods with the same name but has different number of parameters or different type of parameters passed in. So at this level, you have the same method, or you have two different methods that have the same name, but you're passing in different number of parameters. You can say a sum of two integers, and the method will be called sum, and then you pass in two parameters to that method, then it will sum those numbers and gives you back the result. And you can do a sum passing in three or four parameters, and then to do a sum and return that back. That's what we call method overloading. So that would be a perfect example right there. And then another one would be passing in your numbers. If you, in the case of a sum, passing in the numbers as strings. So one would be one in wording, and a different number in a wording form, and you'll be able to take that, convert it accordingly, then do the sum, then give it back your result in a wording form. So that will be a basic example that I can give you for method overloading. And method overriding is a method with the same definition and signature but different implementation. So in the case of abstraction, as we saw, is that we define the method, it is there, it's the same method basically, but the way that we implement it is to cover for each use case on our concrete class or our object. And that's what we want to achieve with method overriding, to achieve polymorphism essentially. And that's it for this tutorial. Just wanted to make it short and simple so that when you see these principles in action, you're not shocked as what's happening. And as I write code, guys, I will be letting you know that, okay, now this is what I'm doing. This is inheritance. We're passing in this class now. This is abstraction. This is what we're adding, and this is why we need an abstract method here. And also for compile time, polymorphism, method overloading. Those use cases I'll be defining whenever I write code, so that you can see these and you can get used to them, so that when you see code, you are not scared of what you're looking at, but you're able to define as what are you looking at, what principle is this, what methodology is this, and how the relationships on the domain objects are defined. And this is it. I just wanted to keep it short and simple. Please do like and subscribe. I really appreciate your views. I really appreciate your inputs. Please do comment, guys. If something is to be improved, please do let me know. And also, thank you for watching. See you on the next one. Cheers.